Welcome to Should Have Known It, where we present 15-minute shows of things you definitely should know. Hi, welcome to Shoulda Known It. I'm Mr. Whitfield, and today's topic is Every Map is a Lie. Here is the fundamental constraint that no cartographer in history has escaped. You cannot flatten a sphere without tearing it, stretching it, or compressing it. This is not a limitation of technology or ambition. It is a theorem, the Theorema Egregium, proved by Carl Friedrich Gauss in 1827, which states that a surface with intrinsic curvature cannot be mapped onto a flat plane without distortion. Every world map you have ever seen is a controlled, calculated lie. The question every projection must answer is, which lies are acceptable? You can preserve area. If two regions look the same size on the map, they are the same size on the Earth. Or you can preserve shape. Local angles and coastline outlines stay recognizable, or you can preserve distance along certain lines, but you cannot preserve all three simultaneously. The moment you choose one, you sacrifice the others. This is not a design choice, it is mathematics. Cartographers call these properties conformality for angle preservation, equivalence for area preservation, and equidistance for distance preservation. A projection that achieves all three is called impossible. The entire history of map-making is a long, creative argument about which distortions humanity can live with, and more pressingly, which distortions serve whoever is paying for the map. Gerardus Mercator published his famous projection in 1569, and he was transparent about what it was for. The title of the original document reads, in translation, "A new and enlarged description of Earth with corrections for use in navigation." Navigation, Mercator built this map for sailors, and for sailors it is genuinely, spectacularly correct, in a way that no other projection of the era could match. The critical property Mercator preserved is this. Any straight line drawn on a Mercator map is a rum line, a line of constant compass bearing. If a 16th century navigator drew a straight line from Lisbon to Havana, measured the angle against north, and held that compass heading for the entire voyage, they arrived at Havana. That is not trivial. That is the entire problem of transoceanic navigation solved. Mercator did not make a general-purpose map. He made a navigational instrument, and it worked. The cost of this miracle is that Mercator's projection inflates everything away from the equator. To preserve angles everywhere, you must stretch the north-south scale to match the east-west scale at every latitude. And since east-west scale increases as you move toward the poles, north-south scale must increase in lockstep. The result is that land masses near the poles are stretched in both dimensions simultaneously. Greenland, which sits at roughly 75 degrees north, is stretched by a factor of approximately 6 in each direction. Its area on a Mercator map is roughly 36 times its true size. Mercator himself knew this. He never claimed his projection showed countries at their true sizes. The distortion was not a secret. It was an acknowledged geometric consequence of the one property he needed. The problem is not what Mercator did in 1569. The problem is what happened next. On a standard Mercator map, Greenland appears roughly the same size as Africa. Let us be very precise about what the same size means here. Greenland's actual area is 2.166 million square kilometers. Africa's actual area is 30.37 million square kilometers. Africa is not twice as large as Greenland. It is not 5 times as large. Africa is 14 times the size of Greenland, a number so different from what the map shows that it should register as a kind of cognitive shock. Africa contains, within its borders, the entire continental United States, all of China, all of India, the whole of Western Europe, and still has room left over. That is not a poetic exaggeration. The United States is 9.8 million square kilometers. China is 9.6 million. India is 3.3 million. All of Western Europe together is roughly 3.9 million. That sum, the US, China, India, and Western Europe combined, is 26.6 million square kilometers. Africa is 30.37 million. Africa is bigger than all 4 of them put together. Most adults shown these numbers do not believe them at first. The website, The True Size Of, allows you to drag any country across a Mercator map and watch it resize correctly as it moves between latitudes. When you drag the United States down to sit on top of Africa, the United States, which looms large and authoritative on every classroom map, fits comfortably inside the Democratic Republic of the Congo alone, with room to spare. When you drag Greenland down to the equator, it shrinks to roughly the size of Algeria. These are not tricks, they are corrections. The scale of this misrepresentation has real consequences. Generations of school children, including almost certainly you, internalized a map in which Europe appears roughly the same size as South America, when South America is actually twice as large, in which Alaska looks bigger than Brazil, when Brazil is 5 times Alaska's size, in which Russia, already the largest country on Earth, looks like it spans nearly half the globe's width, which it does in longitude, but which it does not in area, because those vast Siberian expanses are stretched by Mercator's polar inflation until they dominate the visual field. Mercator's projections survived into classrooms for reasons that had nothing to do with navigation. First, it is aesthetically clean because angles are preserved, coastlines look right, familiar, recognizable. Second, rectangularity. A Mercator map is a rectangle, which fits neatly on a wall in a textbook, on a screen. Third, and this is the uncomfortable part, the projection flatters the northern hemisphere, where European colonial powers were located, making their territories look larger and more dominant than they were. This is not a conspiracy theory. The political utility of inflated northern territories was noted explicitly by critics as early as the 1940s. The German historian and cartographer Arno Peters made this argument forcefully in 1973 when he unveiled what he called the Peters projection, a map that he claimed showed the world as it truly was, with correct areas for every country. He framed it explicitly as a corrective to Eurocentric distortion, and it became a minor political cause. Peters was right that Mercator distorts area. He was wrong that his solution was new. The equal area projection he presented had been published in 1855 by James Gall, a Scottish clergyman, and is now properly called the Gall-Peters projection. Peters was also somewhat economical with the truth about his own map's properties, which brings us to the nature of the compromise. The Gall-Peters projection preserves area perfectly. If Nigeria and Norway look the same size on a Gall-Peters map, they are the same size to an accuracy that Mercator cannot approach. This is a genuine and important virtue, but the cost is shape. To preserve area, the projection must compress or stretch shapes, and what it does to equatorial regions is striking. Countries near the equator are stretched vertically, giving them an elongated, thin appearance that makes them look like they've been through a taffy puller. Meanwhile, countries near the poles are compressed horizontally, looking squashed and unnaturally wide. Russia, in Gall-Peters, looks like a smear. Scandinavia looks like a collection of narrow spindles. The map is technically accurate in area, but perceptually alien viewers who have grown up with Mercator find Gall-Peters almost unreadable. The shapes trigger dissonance. Geographers frequently note that Gall-Peters solves one injustice by committing a different one against geometry. The Gall-Peters projection was adopted by the United Nations Development Program and several aid organizations in the 1970s and 1980s, specifically as a political statement about the importance of the developing world. It was hung in many schools as a counterweight to Mercator. Neither camp was entirely right. Mercator was a navigational tool pressed into educational service. Gall-Peters was an ideological correction that traded one set of distortions for another. In 1963, Arthur Robinson was commissioned by Rand McNally to design a projection that simply looked right, not perfect in any single mathematical property, but visually balanced, intuitively comprehensible, and fair to all regions. His solution was to throw out the idea of perfection entirely and work empirically. He tested different formulas against people's aesthetic judgments and landed on a compromise that is neither conformal nor equal area nor equidistant, but is less wrong about all three than any projection that insists on being exactly right about one. The Robinson projection became the standard for National Geographic maps from 1988 until 1998, when the organization switched to the Winkel-Trapel projection, another compromise, designed by Oswald Winkel in 1921, which minimizes a mathematical sum of all three types of distortion simultaneously. The Winkel-Trapel is currently used by National Geographic, by most major atlases, and is considered by many professional cartographers to be the best general-purpose flat world map available. It is almost certainly not the map you grew up with. Notice what just happened in that sequence. Mercator in 1569 for navigation, misappropriated for classrooms, Gall-Peters in 1855, rediscovered in 1973 as political corrective, Robinson in 1963 as aesthetic compromise, Winkel-Trapel in 1921 adopted as standard in the late 20th century. The correct map has changed repeatedly, not because cartographers discovered new land, but because different eras asked different questions about what correctness means. In 2016, a Japanese architect named Hajime Narukawa won the Good Design Award for the orthograph projection, a map that divides the globe into 96 triangles, unfolds them onto a rectangle, and achieves near-equal area representation with substantially less shape distortion than Gallpeters. It looks, at first glance, bizarre. Antarctica is enormous and sits at the top. The Pacific Ocean is central rather than split across the edges, and the familiar Atlantic-centered rectangle of your school days is nowhere to be seen. This raises a point that cartographers find obvious and non-cartographers find genuinely startling. The choice of which ocean to put in the center of the map is arbitrary. European mapmakers centered their maps on the Atlantic because Europe sat conveniently in the middle, and that convention became so dominant that it feels natural. Pacific-centered world maps, common in Australia and Japan, show the Americas on the right and Eurasia on the left. They are not wrong, they just chose a different arbitrary center, which reveals that the correct orientation of a world map is not a fact about the Earth, but a fact about the culture that made the map. And north-up orientation also arbitrary. Early maps were often east-facing. Orientation comes from Orient East, and several medieval Islamic maps place south at the top. There is no physical reason north belongs at the top of a map. Gravity pulls toward the center of the Earth, not toward the South Pole. If you grew up in New Zealand, a south-up map is just as correct, and makes your country look substantially less like an afterthought at the bottom of everything. The map you internalized in childhood did not just teach you geography. It taught you a set of unstated assumptions about scale, importance, and centrality that are very difficult to unlearn. When politicians and journalists gesture at world maps during coverage of international events, they are usually gesturing at a Mercator map because that is what newsrooms have on their walls, because it is what looks authoritative, because the familiarity of the distortion has become indistinguishable from the truth. Here is a concrete consequence. Nigeria has a population of approximately 220 million people, roughly the same as Brazil. On a Mercator map, Nigeria looks like a small country and Brazil looks enormous. A viewer who absorbs that visual impression without scrutiny comes away with an intuitive sense that Brazil is more significant, more populous, more central to world affairs. The map does not say this, but the map implies it, with the authority of a document that appears scientific. Africa contains 54 countries, roughly 1.4 billion people, the longest river on Earth, the largest desert on Earth, and more genetic diversity among its human population than exists in the rest of the world combined. It sits on a Mercator map, looking roughly comparable to Greenland, a large island of 56,000 people covered almost entirely in ice. This is not a minor cartographic quirk. It is a persistent, systematic misrepresentation of where most of human life takes place. Every professionally produced map today should carry, and sometimes does carry, a note identifying its projection. This is the first thing to look for. If a map does not tell you its projection, treat it the way you would treat a graph with no axis labels, as a document that is asking you to accept its conclusions without showing you its assumptions. A map is not a window onto the Earth. It is an argument about the Earth, made by a cartographer with a set of constraints and a set of priorities. When you encounter a world map showing countries' relative sizes, ask, is this Mercator? If yes, mentally compress everything north of 45 degrees latitude, Canada, Russia, Greenland, Scandinavia, and mentally expand everything near the equator, Central Africa, Southeast Asia, the Amazon basin. The rough correction factor for Greenland, as noted, is about 36. For Canada, it is roughly 4. For the UK, roughly 1.5. For Nigeria, near the equator, Mercator's distortion is nearly 0. Equatorial regions are almost correct. For area comparisons, use Gallpeters or, better, Winkel-Treppel, and accept that the shapes will look unfamiliar. For navigation along constant compass bearings, Mercator is still correct. It is why Google Maps defaults to a Mercator-like projection at street level, where the area distortion is negligible over small distances and the angle correctness is essential. Different projections for different questions. There is no single correct map. There is only the right map for the right question. Gauss's theorem tells us that distortion is not a failure. It is an inevitability when you try to represent a three-dimensional reality on a two-dimensional surface. Something must give. The question is not whether you are distorting, but which distortions you are choosing and whether you are being honest about the choice. This is true of maps, and it is true with remarkable consistency of every other kind of representation. Charts, statistics models, narratives. A model that is perfect in one dimension is almost always wrong in another. The map that is correct for navigation is incorrect for area comparison. The projection that is honest about size distorts shape. The story that captures one truth about an event necessarily omits others. Gauss proved this specifically for spheres and planes, but the underlying principle that you cannot project a complex reality onto a simpler surface without loss turns up everywhere. Cartography is one of the few fields where this loss is precisely quantified and openly discussed. The most useful thing a world map can teach you, then, is not where countries are. You can find that on any projection. It is this: the representation of a thing is not the thing itself. Every map is a model. Every model has a perspective. Every perspective has a cost. The question to ask is not, is this map correct? It isn't. None of them are. But what did this map choose to preserve? And what did it choose to sacrifice? And does that choice serve my purposes or someone else's? Mercator's projection is still in use, 456 years after it was published, because it does one specific job extraordinarily well. It is still on classroom walls because it became familiar, and familiarity became authority, and authority was never questioned. If you take one thing from this room today, let it be a small, precise habit of skepticism. When someone shows you a map of the world, or any model that claims to show you how things really are, ask what it had to sacrifice to look that clean. Mr. Whitfield picks up his satchel, pauses for a moment looking at the map on the wall with an expression that is not quite contempt and not quite fondness, then walks to the door, clicks off the lights, and leaves you in the dark with a globe, which, for the record, is the only map that doesn't lie.
And that brings us to the end. Thank you for joining me. I hope you learned something new. Until next time.